right, let's do this video for Cali Community College. This is Mr. Anderson speaking, and we're going to be doing a rather lengthy video talking about some of the bigger problems at the end of Chapter 2 and the start of Chapter 3. So in problem number 12, finding the domain of the function. Now, what this is going to do for us here is we've got to figure out what values of x would make the problem divide by 0. And a little bit of factoring would help us out here. Knowing some factoring from Chapter 5 is going to make this problem a lot easier, because what we're going to do is factor out the numbers that multiply to make -10 and add to make -3. In this case, this would be -5 and +2. So what this means is that since my denominator can't be equal to 0, so anytime you have a denominator can't be equal to 0, that means that x minus 5 times the quantity of x plus 2 cannot be equal to 0. So that means x minus 5 cannot be equal to 0, and also x plus 2 cannot be equal to 0. So x cannot be equal to 5, x cannot be equal to 2. So the domain is the set of all real numbers for x, with the exclusion of x cannot be equal to, in this case, oops, forgot my negative there, -2, and x also cannot be equal to +5. But every other value of x that I plug in for this problem will not give me a division of 0 error. But if I plug in 5, or if I plug in 2 in this case, I'm going to get 0 in the denominator, and that's going to mean that the problem is undefined at those two spots. So there's my domain. We're going to see a lot more domain problems in this practice test here, so we'll keep referring back to them. So what I'm going to do in problem 13 is I'm going to start off with 3 equations and 3 unknowns. The general step of solving a equation or a system of equations with multiple variables is you pick a pair and eliminate a variable. And then after you're done with that, pick a pair and eliminate the same variable, and then just keep working it down until you get to one variable all by itself. I'm going to pick the first 2 lines and I'm going to stack them up and eliminate the y's. This means I can keep the top equation exactly the same. So 2x plus -2y, which is the same thing as writing 2x minus 2y, plus 3z equals 5. And then down here, I'm going to multiply this by 2. This is going to be 4x plus 2y minus 4z equals -2. So everything got doubled here. And now I'm going to combine these and put them together. So this makes 6x, these go away to make 0, -z, and this is +3. Now I'm going to pick another pair of these. I can't pick the top and middle one. I'm going to pick, in this case, the middle and bottom one, because what I'm going to get is the y's to simplify, and I don't even have to change anything. 2x plus y minus 2z equals -1, and 4x minus y minus 3z is equal to 0. And you can see that I don't need to change anything, so I just stack them up here. I'm going to go 2 and 4, which makes 6x. These y's make 0, and this makes -5z, and this makes -1. I'm now going to stack these 2 equations on top of each other and eliminate one of the variables. Probably easy to eliminate the x's. So I'm going to take this first equation and multiply this by -1. So -6x plus z equals -3. And I'm going to take this equation and just keep it the same. So it's 6x minus 5z is equal to -1. So what this makes over here, this 6x's simplify to 0. This makes -4z equals -4. Z is equal to 1 when I divide both sides by -4. Well, this is a promising start here. I'm now going to plug this z, or this 1 for z, back into one of the original equations. I like this one right here. I'm going to plug this 1 back into this equation. So now I get 6x minus 1 equals 3. So 6x is equal to, if I add the 1 to both sides, 4. X is equal to 4/6, or 2/3. So my x is equal to 2/3. So now what I will do is I will plug the 1 and the 2/3 in for one of my 3 equations up here and solve for my missing letter, because I've solved for x, and I've solved for z. Now I'm just going to have to solve for y. So the equation I'm going to choose to plug it into is the top one. It has the fewest number of negatives. So now I have 2 times 2 thirds minus 2y plus 3z is equal to 5. But I'm going to plug, instead of my z there, forgot to put my 1 in there. Okay, so 2 times 2 thirds is 4 thirds minus 2y plus 3, because it's 3z, so 3 times 1 is 3, is equal to 5. I'm going to kind of creep over here a little bit with my work, so I'm just going to drag it over. So now what I have is I'm going to have my negative 2y is equal to 5 minus 3 minus 4 thirds. So negative 2y is equal to 5 minus 3, which is 2 minus 4 thirds. If I'm not using a calculator, I can get common denominators here. So to put this over 3 is going to be 6 thirds minus 4 thirds, because that's what 2 is as rewritten as thirds. So negative 2y is equal to 2 thirds, positive 2 thirds in this case. I could divide both sides by negative 2, but I'm going to multiply it by negative 1/2. It's the same as dividing by negative 2. And again, this is all without a calculator. Again, this would be probably easier with your calculator. All right, so these can't simplify out. So y is all by itself. Now we're going to figure out what this is. The 2's simplify here, because you get, 2 over negative 6, which is going to simplify down to 1/3. All right, so there's my equations, x, y, and z. So x is 2 thirds, y is negative 1/3, and z is 1. And there it is, folks. There is your answer for problem number 13. Now let's look at a weird one. This is problem 14. I think it's weird just because you can see that one of the variables is already eliminated, and the variable that's eliminated is y. So I'm going to put my top and bottom equation together to eliminate the y's, and then compare it to my equation here in the middle, which is x plus z. And the way I'm going to approach this problem is, since the second equation doesn't have a y in it, if I just put the top and bottom equations together, I can do the problem, eliminate the y's, and then compare it to my equation in the middle here. Okay. All right, let's stack these up and make it happen. Now the 3 and the negative 3, they make 0. The negative z and the 2z, that just makes 1z. The y is simplified to 0. And this makes 3x plus z equals 0. Now I'm going to compare it. I'm going to take this equation, and I'm going to take this equation here, and I'm going to stack them on top of each other. But since I want like the z's to cancel out or simplify to 0, I'm going to take the second equation and multiply by negative 1. So my top equation, I'm going to leave it as 3x plus z equals 0. And the bottom equation is going to be negative x minus z equals negative 2. So this means now I have 2x is equal to negative 2. So x is equal to negative 1. So now I solve for my x. I'm going to plug that back into my equation right here. So negative 1 plus z equals 2. And if I just solve for z, z is going to be equal to 3. Now I know my x, now I know my z. I just need to plug this back into one of my other two equations, because the middle equation doesn't have a y, just to figure out what y is. Well, let me look at this here. I'm going to plug it into the top equation. So therefore, I've got my x plus y plus z equals negative 3. So y is going to be equal to negative 3. I'm moving my 3 over, negative 3. And then I'm going to add my 1 here to this problem. Let's see, let me make sure I'm doing this right here. Negative 1 plus y. Oh, okay, so here's the thing. You see how that was a minus z? So that becomes a negative 3. So this becomes negative 3 plus 1. I saw where I made my mistake there. You see, negative z, plug the 3 in there, should be a negative 3. So y is equal to positive 1. So my answer to this problem is going to be negative 1, 1, and 3. All right, one more problem to go here for this rather long video here, talking about these systems. Something interesting is going to happen here. And in this case, I'm not going to... Let's see, which letters do I want to eliminate here? I think I'm going to eliminate the x's. The x's seem to be a good choice just because I won't have to manipulate stuff as much. I'm going to basically combine these two lines and multiply the top line by 2. This gives me negative 2x plus 6y minus 8z equals 12. And then down here, this is 2x minus y plus 3z equals 10. Okay, so the x's simplify out. This gives me 5y. This gives me negative 5z equals 22. Okay, so now what I'm going to do is maybe combine the top line with the very bottom. So I'm going to multiply the top line by 5. So it syncs with the one on bottom, and the x's simplify pretty easily. So this is going to be negative 5x plus 15y minus 20z equals 6 times 3, 30. Now I take my bottom equation with no modification whatsoever. All right, so now what we do, see the simplification. This makes 5y minus 5z equals 38. And now we have a problem, because if we stack these two equations on each other, and just for fun, if we turn all of this multiply by negative 1, turn it all opposite or negative of what it once was, what you see, what we have here is a paradox, because these both simplify and 0 is equal to, well, not 0, it's equal to negative 18. And this means that there's no solution. These two of these three planes are parallel. We don't actually know which ones are parallel. Technically, all three of them could be parallel. But it just means that we have no solution. And again, that looks kind of sloppy. So here we go. No solution. There we go. There's no solution to the problem since we have this paradox. It is possible to have like 0 equals 0 in another type of problem like this. And then you would say that they'd be all solutions because some of the planes would be lying on top of each other. So thank you for watching the video, and thanks for being patient. Just be meticulous about these problems. Just take your time, slow down, and try to do a good job on these. All right, thank you for watching.